Welcome to the Ocean Virtual Laboratory. The first thing that you will see is the base map. You can choose one out of two different backgrounds. Then you can zoom in to the area that you're interested in. You can also freely move the window content by dragging it. You can also check the scale, which is placed on the right side of the window. After clicking arrow on the left, a panel appears that contains a list of products that can be visualized in the OVL system. Let's have a look at the sea surface temperature. At the bottom there is a panel where you can modify the time parameters. For example, aggregation in time. The daily means that all data present for the exact date will appear on the screen. Then you can choose this date manually by clicking on the year, the month and the day. You can choose out of days that are depicted in white. After clicking the dataset, its name appears in the panel and you can easily find it afterwards. The region of South Africa is very interesting because of intensive mixing of water masses from the Indian Ocean and from the Atlantic Ocean, due to the presence of very fast and strong western boundary current, which is called the Agulhas current. It transports warm water masses along the African coast, and after passing the Cape, it turns west, just to retroflect then towards east, causing occurrence of very characteristic meanders that can transform into natal pulses, which drive exchange of salt and heat in this area. To look closer at the temperature gradient, you can use the SST maps from the VIR sensor, which has a resolution of 1 kilometer. Define the matchups. Enable the collocation option in the settings panel. Then the dates that will contain both datasets will appear in red. Now you can exactly see the strong temperature gradient. Moreover, you can see a temperature drop near the coast, even though there are present clouds near the shore. This decrease in temperature is caused by coastal upwelling, which occurs in a certain wind conditions. When you look at the wind barbs, you can see that there is a wind blowing around the African coast. Because of the Coriolis force that influences water masses, the surface waters are pushed away from the coast and substituted by the deeper waters that are cooler and richer in nutrients. Such conditions are favorable for phytoplankton growth. So while we compare it with the chlorophyll A concentration map, you can easily see the zone of high primary production, which appears in red. It is a very frequently occurring phenomenon near South Africa. To better depict the water movement on the surface, you can display the surface current streamlines. They are calculated based on the SST radiometer data and altimetry data. Although both layers are calculated based on different sources, you can see that the water flow and the surface patterns are similar on both layers. The water flow is depicted in the form of an attractive animation that helps to imagine the water movement. Because of the Coriolis force that influences water, a phenomenon called Ekman pumping occurs, and the water rotating anti-clockwise causes water to pile up inside the eddies. In these regions, appears significant increase in the sea surface height visible on the altimeter profiles. You can see increase in the sea surface height where the water masses rotates anti-clockwise, and the depression where the water rotates clockwise. You can also see the temperature and salinity of the deeper water masses thanks to the data from Argo profilers that was included into the OVL system. The Argo profiles are symbolized by small icons. After clicking them, a profile of temperature and salinity appears with the name of the dataset in the title of the window and a short description of the profile. Additionally, you can share your screen and show a friend what you're looking at by generating a permalink. It's a unique link that is generated for you. After opening it, you will see exactly what is on the screen now. The same layers and the same region of interest. Try using the Ocean Virtual Laboratory yourself.